Hello from Farland. Today's pretty exciting. I've got a new product I want to introduce to you. It's a product that will control signals for bidirectional traffic on a single line. I don't think there's anything else out there like it. It's a product from Azatrax, and it's really a great product. I have it installed on my layout now, and I'm tickled with it. I'll show you how it works. This system mimics semaphores, except in colored lights. So as they were making the transition from semaphores to colored lights, they kept the same concept, only expressed in colored lights. Eventually, they moved on to more sophisticated signaling arrangements, but in the 60s, in the conversion, this is what they had, or this is based loosely on what they had. I've watched a number of those old signaling training films from back in the day, and I've often wondered how I could duplicate it on my layout. This is the answer. This is how I laid out the signals on Farland. This is the incline up the hill. The castle's right here, just to get you oriented. So if a train is coming this way, it passes the distant down signal, and then it passes home. If home is green, it can enter the station. Same coming the other way on the up line, or going in the up direction. You go past the distant. If the distance yellow, that means the home is red and you must stop. And when it's green, you can proceed into the station. When the starter is green, you can then continue on your way. Some would say that this home signal should be located right behind the starter, but I have a level crossing here, so I moved it back a ways. I just didn't feel like the Farlanders would enjoy being stopped at a level crossing quite frequently if the traffic was heavy. And whether or not this is a safe stopping distance is not really known. And whether this signal is actually located further away, further down the line. And I think it is a safe stopping distance. I just didn't want the trains to have to start slowing down on the hill, because they're going uphill if they're going this way. So that's the way I laid them out. This diagram from the manufacturer shows where the signals are in relationship to the sensors. Distant signals must be located a safe stopping distance from the home signals. This sequence approximately mimics British Rail signal operation in the early days. I don't know if you've watched some of those early day signal training films, but I really have enjoyed those. In the kit, you will get the circuit board sensors, which includes the sender and receiver, plus mounting screws with spacers. One can either mount the sensor, sender, and receiver units across the track as illustrated, or in the reflective mode as illustrated. Reflective mode is where the sender sends infrared light up and it reflects off the bottom of the train. I have a number of signals that I control this way. I also have a few that I control with across the track sensing, and we'll show them to you in a minute or two. Connecting wire to the terminals on the unit could not be easier. You press down a button on the terminal block and then insert the wire into the proper terminal and release the button, which locks the wire in place. Easily removed as well. These diagrams illustrate how to connect the sensors on either the left using across the track mode or on the right using reflective mode. Depending on the mode, the wires are connected to different terminals, which is clearly illustrated. This picture illustrates the wiring diagram for signals and the interface controls. On the left is illustrated where the switches go on the terminal block. T1 and T2 mirror each other's functions, while T3 and T4 do other things to operate the system. This diagram explains what the switches do. When the system starts up, it doesn't know if there's a train in the station, and if there is, what direction it will be going. You must tell the SHS which way it will leave by momentary closing of T1 or T2. I've used a push button in parallel with the switch to simplify it. That way I can set up the direction with the interface by a quick push of the button. The other way you can do it if you don't want to buy a button is to quickly close the switch and reopen it. You can also close and leave it closed, which will keep it green in that direction, and trains don't need to stop. T3 makes all the signals red by closing it. This holds the train at the station. It can be a lot of fun operating it. Although the SHS is automatic, it will also allow you to control the functions to override the automation. The wiring and the interface is not complicated. This is the way I wired mine. I put the designations T1 and T2 numbers as labels under the proper switch so I could tell which was which without flipping it over. You'll notice I rearranged the order of the switch from the diagram to a more logical way for me. Now let's look at some applications of across-the-track sensing and reflective sensing under the track on my layout. For my level crossing, I used across the track because there are 3 tracks and it was much easier. This is where I hid one sensor. If you see this little building back here, one of the sensors is looking out the window. The other sensor is hidden in this bush. Let's see if we can get a look at it. It's right there. If something comes along and breaks the beam, it causes my lights to flash. Trains coming from the other direction I'm not sure we're going to be able to see this, but there's one down here looking that way, and there's one over here looking that way. So it's about 20 inches apart or so, I would say. As far as reflective sensors, here's a pair right here. I think those are more vertical because it was a difficult spot to angle them. And having them vertical, as long as they're a proper distance apart, will work too. Let's see, I know there's some sensors under here. There's a pair of angled ones. So they're around, but unless you know they're there, they're really not very visible.